First, hello everyone. Let's see NAND gate layout with respect to cadence tool. First, I am creating new folder on the desktop, naming delete underscore NAND. So it is 2 input NAND gate. So NAND2 I will put create. I'll open this folder. Inside this, right click on open in terminal. Now here I am invoking my C shell. Through that I am invoking my cadence tool by giving the command. After this, virtuoso. So my library manager window will open. So here tools, library manager, in this file again, new library. So I need to create my library. NAND2 is my library. I'll click on OK. Attached to an existing technology library, OK. Then here GPDK 180, OK. After this, your library is created. NAND2 here, you check, yeah, it is here. NAND2 is here. So adana select you select that and then go to file, new cell view. So here new file is window will come, pop-up window. Here library name is NAND2, cell name also you give it as NAND2. Okay, you can give NAND3 or any name also, but the same name will be handy. Now schematic window will open. Here I on your keyboard, it means add instance. So I from the keyboard. Library you need to select as GPDK 180 itself. Then here the cell you have to include is PMOS. 2 PMOS transistors in the pull-up region, 2 NMOS transistors in the pull-down region you require here. I will select PMOS, I'll click enter twice. Now I'm going to place that particular transistor here, one transistor here and one more PMOS transistor here. Then escape. Again I from my keyboard. Through the GPDK 180 library itself, I am going to invoke NMOS transistor, double enter. Then after selecting that, now I am placing this here. Now escape. Now after placing these transistors, I need to place my VDD BSS pins. For that, P from my keyboard, that is create pin. Name is VDD space VSS. I'll then click hide. First these two I will insert. Now VDD is here. R means rotate. I will press R thrice, that is 3 times, and then I will place VDD here at the top. Now VSS is coming through my mouse pointer. This also I will rotate twice and I am going to place here. After placing this, escape, click F. F means fit to window. Now I need to give my 2 inputs A, B and then my output V out or Y. So let us take input. For that, P on my keyboard. So my inputs are A and B. Let me take small a itself, small a comma small, not comma, small a space small b, hide. So A you can place over here. So place little far away. So here I have placed A, here I have placed B. Then escape. Now I need to place my output Y or V out. Let me take it as V out. P from my keyboard. First you change the direction to output, then you give V out. Then click hide. Place over here. Escape. Now W from my keyboard to wiring, for wiring. So these 2 terminals I need to short. And this particular NMOS drain to this junction, and these 2 terminals of my PMOS has to be shorted. After this point to this point, from here to here, then this junction to this V out. Or you give from here to here, that's better. Then from this A to this point, this B input pin to this gate. Then after this you need to connect this substrate terminal to VDD. This substrate terminal also should be connected to VDD. Then you have to connect this particular terminal to VSS or ground, and even this particular terminal also should be connected to ground. Now next is these gates have been opened, even this also you need to connect. So I will connect this first one to A, the second one to B. For that, like this I have connected. So all connections have been made now. F on your keyboard, fit to window, escape, that wiring tool will go. Now I have to click on check save. So if any error is there, one window will pop up. Since there is no error, there is no error message which was popped up. Now again cross check that by clicking on this Virtuoso window. Here schematic check completed with no errors. NAND 2 schematic is saved. So this message we should get. So after this, what we have to do is create cell view from cell view. So I'm going to generate the symbol now. So library name is NAND 2 itself. Everything has to be same. Do not change anything. Click on OK. Now here input left pins are AB are left pins. VDD is a top pin. So Control X, Control V. VSS is a bottom pin. Control X, put it on bottom pin. And unnecessary space if you have, you delete that in the left pin. Then you click OK. So after this symbol is generated now. So F on your keyboard. At part name, this is not required, delete. At instance name, not required, delete. Do the check save again. So if there is any error, pop-up window will come. Since there is no error, no pop-up window came. So go to Virtuoso window, check for this. Completed with no errors. NAND 2 symbol is saved. So earlier NAND 2 schematic is saved we got. Now it is, since it is a symbol, we got symbol here. Now come here. Initially, one more time you click on check save and then you close this. Close the schematic also. Now come to this library manager. I'm maximizing this library manager window. So NAND 2, it should be selected. Go to file, new cell view again. So click here. So here now NAND 2 is my library name. Let it be as it is. My cell name is NAND 2 underscore test or TST, anything. Let it be all these things in schematic view only. Click on OK. Schematic window will open. So in this particular window, again I from your keyboard for adding instance. So what you are going to add? Symbol what you have generated for NAND, that you have to add now. So the library what you have created is NAND 2 library. In that cell name is also NAND 2. I've selected this, click on hide. So the symbol will come, put it here. Escape. Then I need to put VDC also. For that, I from my keyboard. Then library you have to select it as analog lib. Cell name is VDC. Enter twice. So VDC I'm going to enter in the top view. First rotate and then insert. So I'm rotating here. I've placed. Escape. Then I need to select this particular thing, VDC, and then right click on properties. So here DC voltage, in place of DC voltage you give it as 1.8. Just give 1.8. V it only will take. Click on OK. So VDC you are given as 1.8. Now again I from your keyboard, you require ground also. So in place of cell you give G and D and then enter twice. You require one ground over here for negative VDC, one ground for VSS, and one ground you require, yeah, two outputs. Yeah, that's it. Two grounds are enough. Escape. Capacitor if you want you can place here, otherwise not required. Now what you have to do is, now input pin AB, output pin Vout you need to give. So P you have to select. So names Vout you give, then hide. So here I'm going to place escape. Then I'm going to click on P again. So here direction you give it as input, name is A space B, enter. So A you give here, B you give over here, then escape. Now W you take wire, you need to do the wiring again from this A to this A, and then from this B to this B. After this particular VSS should be connected to ground, then this particular point should be connected here, and this particular point should be connected to this ground. Then from here this V out to this V out. So this is the simple connection. Click on escape, press F, fit to window. Now you have to do check save. After check saving, if there is any error, it will show. Since there is no error, it will not show anything. Go to launch, click on ADE. So your ADE window is open. So by default it will minimize. Sometimes you maximize that window, and then go to setup first, and then model libraries. Here you have to select only 180 nanometer technology gpdk.scs file. Only that file is required. Apply, OK. Only tick that, and then remaining untick. Then again go to setup, click on stimuli. Then you have to give input over here. A, click on A, first input, enabled, you tick. 1 value is 1, 0 value is 0, delay time 0, rise time 1 nano, fall time is also 1 nano, period is 20 nano. Then pattern data, you give it as 1011 or 101300, anything, any 4-bit pattern you can give. Click on apply, then select B, again click on enabled. See, A is now on, B is off itself. Now if I apply after enable, after giving one value, all these things, then it will show. So same here also, rise time 1 nano, fall time 1 nano, period is 20 nano, and then parameter data 0010, anything we can give. Then I have to, that's it. If I give apply, then we can see B is on. Yes, B is on now. Click on OK. Then I have to click on analysis, choose. I require only transient analysis here. Stop time is 200 nano. Click on moderate. OK directly. Then click on outputs, setup, from design, input line, 2 input lines, and 1 output lines I need to select. Then click here, OK. So come to ADE window, everything is there here, just run it. So we got to wait for 5 seconds to get the output. Yes, we are getting the output, we got it. So this is the waveform. So I'm going to split this waveform, and I'm going to change the solidity of this waveform. So color also I change. Solid line. Color I'll change it to some other one. Width is thick. Width is thick. Type style is solid. Yes, so we are getting the output. Just to cross check, above one is my V out, this is my B input, below one is my A input. Whenever my A input is 1 and B input is 0, 1 into 0, 0, no charge, NAND gate is 1. So that 1 we got here. So like that, 0 into 0, 0, but 0 bar is 1, so 1 we are getting here, NAND output. So here 1 into 1, 1 AND gate output, but NAND gate output is inversion of that 0, so that 0 we are getting here. So similarly for the last case. Thank you.